Welcome back, ladies and gentlemen, to another exciting JLand Bio video. I'm super excited today to be talking to you about work and energy. And trust me, I know a lot about work, teaching both regular face-to-face and online classes, but I'm not talking about that kind of work. I'm talking about physical, mechanical work. Hopefully by the end of this video, you should be able to explain work and calculate it, and understand how machines can create mechanical advantages and efficiency, and differentiate between kinetic and potential energy, and be able to calculate both. So let's talk a little bit about work from a physics perspective. Work from a science perspective is force applied through a distance. So think about pushing a lawnmower. As you push the lawnmower, you are applying a force, and the lawnmower moves a certain distance. So you can calculate the amount of work by knowing the amount of force you apply, as well as the distance that the object travels. So again, work can be calculated. Work in joules is equal to the force in newtons multiplied by the distance in meters. So pretty straightforward to just simply plug those into your calculator and solve for the right answer for work. You push a refrigerator with a horizontal force of 100 newtons. If you move the refrigerator a distance of 5 meters while you were pushing, how much work did you do? Well, remember that work is equal to force times distance. We can simply plug in and solve. Work equals force, so that's 100, times distance, 5. So our work is 500, and don't forget your unit, joules. Okay? So again, just some simple algebra there. If you get two variables, you can solve for the one that is unknown. Let's move on. So you can only do work on an object while applying force to it. When the force is perpendicular to the motion, the work from that force is 0. So a good example of this is you're carrying your textbooks in your arms, right? The work that you're doing is holding the textbooks from falling to the ground. That is on a vertical plane. If you are walking with the books in hand, you are not doing any work in the horizontal direction. It seems a little bit weird, but when an object is carried at a constant velocity by a force which acts at right angles to the motion, no work is done on the object. So you're not actually doing any work, because the books are not moving in that particular direction. Simple machine is a machine that does work with only one movement of the machine. And there are 6 simple machines that you're going to want to know: a lever, wheel and axle, pulley, inclined plane, wedge, and screw. Twisty part of the screw, that's what we're looking at for simple machines here. Now, we can take simple machines and combine them together to create complex machines. And a complex machine is a machine that is made of more than one simple machine. So for example, a pair of scissors has 2 wedges, the blades of the scissors, and 2 levers. We combine these simple machines together in order to make what is known as a complex machine. Now, the efficiency of the complex machine is the ratio of output work to input work. Essentially, efficiency is the output work over the input work. Now those will be in joules, and this is a percentage. So we're looking for efficiency in terms of a percentage. So as a result, you need to multiply whatever value you get by 100. You do 20 joules of work pushing a crate up a ramp. The output from the inclined plane is 11 joules. What is the efficiency of the inclined plane? Well, remember that efficiency is equal to output over input times 100. So we just simply plug our variables in and solve. Efficiency is going to be equal to the output, which is 11, divided by 20 times 100. And so we plug that into our calculator and solve, and what we get is a 55% efficiency. So pretty straightforward to go through and complete those types of practice problems. Let's move on. So how are machines useful? Well, they can perform a variety of functions to help us with our everyday lives. I go back to the example of the inclined plane example. It's very difficult to take materials and move them into a truck, especially if they're very heavy materials. But by using a ramp, we can actually increase our efficiency by making things a little bit easier by utilizing the simple machine. Same thing with a pair of scissors. It's a lot easier to tear a piece of paper in half by utilizing a pair of scissors as opposed to, using your bare hands or something else like that. So simple machines are useful for a variety of ways. It can increase speed. It can change the direction of the force. It can increase the amount of force. So in a similar way that we can calculate efficiency, we can also calculate something called mechanical advantage, and that is the ratio of input force to output force. So simply put, the mechanical advantage is equal to your output force, which would be in newtons, divided by your input force times 100. A crate weighs 900 newtons. If you can use a pulley system to lift that rate with a force of only 250 newtons, what is the mechanical advantage of the pulley system? Well, in this instance, this 250 is actually how much effort we have to put in order to get an output of 900 newtons. So we just simply need to plug those into our equation and solve. 900 newtons divided by 250 newtons, and then we solve. And what we end up with is an efficiency of 3.6, meaning that the efficiency of the device is 3.6 times that of what we would normally have to put in. If a crate weighs 900 newtons, normally we're going to have to put in 900 newtons in order to get that. But because we only have to put in 250 newtons, we're 3.6 times more efficient, or have a 3.6 times greater mechanical advantage by utilizing the simple machine. So it's really important to understand that energy is just basically, like I said, the ability to cause change. Energy can be found in lots of different forms that you can see there on the right-hand side. It's really important to define our system versus our surroundings because that helps us understand the input and output of energy provided. The reason we have to do this is that there are lots of different factors that play a role in how energy is transferred in a system. So if we define it really well, we can then concentrate on the energies we're trying to look at. The system is what we are trying to look at in terms of energy transfer, while the surroundings is literally everything else in the universe. And as you can see on the right-hand side here, there's lots of different types of energy that you may want to consider. The main one we're going to look at is kinetic energy, or energy due to motion. Kinetic energy is the energy that is found in objects that are moving. The formula for this is 1/2 times the mass times the speed squared, or kinetic energy is equal to 1/2 mv squared. We simply plug in our numbers and solve. A jogger with a mass of 60 kilograms is moving forward at a speed of 3 meters per second. What is the jogger's kinetic energy? Well, remember that kinetic energy is equal to 1/2 mv squared. So we just simply plug in and solve. Kinetic energy is equal to 1/2 the mass, which is 60, v, which is 3, and we're going to square that value. When we get to the end, we get kinetic energy, which, as you know, energy is measured in joules, so make sure you include the correct unit with your response. And what we get is 270 joules of energy. Okay. So again, pretty straightforward to be able to plug in and solve for any one of these types of problems that you may find. Potential energy is the energy that's stored within objects. So a great example is a roller coaster. At the very, very peak, at the height of the roller coaster, the coaster itself has very, very high potential energy but low kinetic energy, right? There's a lot of energy stored in being that high. There's lots of energy being stored that high, but you're not moving very quickly as you go up the top. Once you then start going down the roller coaster, that potential energy is then released into kinetic energy. That's why the coaster continues to move. Another example of this is a spring. Elastic potential energy, or the energy stored by compressing or stretching an object. You know, when you fling a rubber band, as you move the rubber band back, it has high potential energy. It has a lot of energy in order to be able to, it has a lot of energy that's stored within the object itself. That potential energy is turned into kinetic energy once you release the rubber band, causing it to go very, very far. Again, kinetic energy, moving energy. Chemical potential energy is the energy that is stored in chemical bonds. So you know that either you make or break chemical bonds, you either store or release energy. You learned that from biology class. And then gravitational potential energy is the energy due to gravitational forces between the object and the Earth. Gravitational potential energy is very easy to calculate as well, as it is the mass times the gravity, or the acceleration due to gravity, which is 9.8 meters per second squared, multiplied by the height. So again, you're going to get several different variables, and then you can plug in and solve for the one that you do not know. A 4 kilogram ceiling fan is placed 2.5 meters above the floor. What is the gravitational potential energy of the Earth ceiling fan system relative to the floor? Well, again, our gravitational potential energy, or GPE, is equal to mass times the acceleration due to gravity times the height of the object. We're given mass and height. Remember that gravity is always 9.8 meters per second squared. So as a result, we can calculate gravitational potential energy. We just plug in. So GPE is equal to 4 multiplied by the acceleration due to gravity multiplied by the height. And then we can plug this into our calculator and get gravitational potential energy. And what we get is 98. And again, because we're focusing on energy, the unit for this is going to be joules. Okay? So again, just plug your numbers in and solve. Just make sure that you utilize the correct formula when you're calculating these particular problems. Let's move on. Well, hopefully today you found the content pretty straightforward. Again, by the end of this video, I'm hoping you're able to explain work and how to be able to calculate it, understand how machines can create mechanical advantages and increase efficiency, and hopefully differentiate between kinetic and potential energy and be able to calculate for both kinetic energy and gravitational potential energy. Thanks again so much for watching, guys. I appreciate your time. Make sure you like and subscribe. Shop merch. I got a merch shop. Make sure you check that out. And we will talk to you guys later. Take care, everybody. Bye-bye.